Hello and welcome dear Mathletes once again to Mathlete Mind. Have you ever wondered why a projector never distorts the shape of the object that is enlarging in size? Here the underlying principle behind this is the light travels in a straight line, hence the angles of the original picture are retained, and if the angles are retained, the proportionality of the size is bound to follow. This is the same principle that we apply in similar triangles. If we take two triangles and if we can find out or judge that the angles are equal, then the sides are definitely going to be proportional, and similar shape plus proportional sides is the core idea behind similarity of triangles. So before we go into the depth of this particular chapter and understand or solve questions based on it, let us have an idea about the real life applications of this particular topic, because it is not a very abstract topic. It has a number of real life applications. Some of the very simple ones we'll be discussing over here. The first one, of course, as you can see, is a huge tree, and the heights of huge trees and buildings can be measured with the help of shadow formation, creating similar triangles so that proportionality relation can be applied. Even when we talk about maps have a particular scale factor, and again with the help of proportionality relation, the particular length that is required, the distance that needs to be measured can be calculated. Even in the construction department or the engineering field, we have bridges and trusses being constructed in stadiums or in bridges over the rivers, where you find the similarity of triangle plays a vital role in the stability of the particular construction. If we talk about the skyscraper models that are prepared, it is based on the AA criteria similarity for constructing blueprints for skyscraper models. When we talk about the camera, the triangles may reduce in size, but they stay similar. So these are very simple applications. Of course, there are innumerable more applications, but we'll be applying some of these questions. We'll be solving some of these questions in the later on videos. Initially, let us try to understand what are the three criteria which allow us to put a particular triangle or categorize two triangles as similar triangles. The first criteria, golden criteria, is AAA criteria. What does this mean? It means that if in any two triangles you have the three angles of one triangle being equal to three angles of the other triangle, then the two triangles become similar. Now, when we write down the similarity criteria, we have to be very careful about writing the two triangle similarity criteria. Here, as you can see, triangle ABC is similar to triangle DEF. That means angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. If there is a change in writing down this, if the proper correspondence relation is not framed over here, then the whole idea goes incorrect, and the basic concept of doing the solution becomes incorrect. Even when the triangles are oriented differently, or if they are flipped, or if they are triangles within a triangle or triangles within other figures, if they are initially similar, then they remain similar, whether they are changed in or they are rotated, or they are inverted, or they are flipped. The second criteria that is there is SSS similarity. Now, what does this mean? It means the three sides are proportional. Here we are not talking about the equality of the sides, we are talking about the proportionality of the sides. So here, as you can see, we have two triangles, ABC and DEF. So AB by DE, the ratio that we get will be equal to BC by EF, and it will also be equal to AC by DF. If all the three sides have the same ratio, then they form a proportion. And once we get this proportion, we can write down the similarity criteria. Triangle ABC is similar to triangle DEF. ABC is similar to DEF. And you can even check it out from here. ABC is similar to DEF. If you want to rewrite this, supposing you are given the similarity and you want to write the ratio of the sides, you must take it in accordance in a particular format, like AB by DE will be equal to BC by DF will be equal to AC by DF. So the relationship can be find out when you are given that the two triangles are similar. The third criteria is SAS. SAS means side angle side. So here two sides are proportional, and as A is included over here, it means the angle must be included within the two proportional sides. If it is some other angle, then this cannot be applied. This criteria cannot be applied. So here AB by DE is equal to AC by DF, and the included angle A is equal to included angle D. Triangle ABC is similar to triangle DEF. So basically these are the three criterias. The first one is AAA, the second one is SSS, and the third one is SAS. Now let us try to understand them with the help of some simple, very simple questions, direct questions, and see how we apply these criteria in solving our questions. So here we have two triangles ABC and PQR. Now as you can see, the angles of both the triangles are equal. Like angle A is 40 degree, angle Q is 40, angle B is 60, angle P is 60, angle C is 80, and angle R is 80. So here when I write down the similarity criteria, A corresponds to 40 Q over here. So my triangle ABC will be similar to triangle QPR. These two triangles will be similar. If you write it as PQR, the whole answer goes incorrect because P does not relate to A. You have to have the correct correspondence over here. The correspondence relation between the angles and the sides must be absolutely correct. In this triangle, we have AB by DE. If you look at the numbers over here, AB by DE will give us this ratio. AB by DE gives us half. If I take the ratio of BC by EF, BC by EF, that also gives me half. If I take the ratio of AC by DF, that also gives me half. So all the three ratios are equal to half. That means they form a proportion. All the three sides, the ratio of the three sides form a proportion. That means triangle ABC is similar to DEF. Triangle DEF. These two triangles are similar over here. So this was application of SSS. This was application of AAA. Moving on to the next question. Here we have the application of SAS, the third criteria. Now here you can see AB is 4 root 3, PQ is 8 root 3. So if we take out the ratio of AB by PQ, that will be equal to half. If I take the ratio of AC by QR, that will also be half. And the included angle is 40. So when I say triangle ABC is similar to which triangle over here, it will be equal to QPR. Triangle ABC will be similar to triangle QPR. Because ABC and QPR, if you write down the proportionality, AB by QP is equal to BC by PR is equal to AC by QR. So that is what we have to understand, and when we write down this, we have to be extra careful whether we are writing it correctly or not. In this question, as you can see, there is a triangle within a triangle. So again, important aspect that is given is one angle AST is equal to angle ACB. So if you take the triangle AST and ACB, angle A is common to both the triangles, and angle AST is given equal to angle ACB. Angle A is common, the common angle. So we get here two angles which are equal. So the third angle has to be equal by angle sum property. So we can write down triangle AST is similar to triangle ACB. These two triangles are similar. Moving on to the next question here. As you can see, ABCD is a trapezium, but it is not mentioned in the question over here. But the ratio of the sides AO by CO is equal to BO by DO is equal to half. This is given. And we are given the measurement of AB as 5 centimeter. And the measurement of DC is supposed to be found out. Let us take it as X. Now if I take the triangle AOB, consider the triangle AOB and the triangle COD. In these two triangles, vertically opposite angles, that is angle AOB is equal to angle COD. This is one pair of vertically opposite angles being equal. Vertically opposite angles are equal. Then we are given the ratio over here AO by CO. So if we consider these two triangles, as I've already said, we get the two sides here proportional and the included angle equal. So I can write down triangle AOB is similar to triangle CO. So these two triangles become similar. And when we write down the proportionality relation here, once again, AO by CO is equal to BO by OD is equal to AB by CD. Right here, OB by OD also doesn't make any difference. So now all these ratios will become equal to half. We have proved that the two triangles are similar by SAS criteria. The triangles are similar. So the third side and the remaining angles are definitely going to be equal, corresponding. Sides and corresponding angles are going to be equal. So now I can write here the proportion is also equal to AB by CD, that is equal to half. But AB is given as 5 centimeter. We know AB by CD is given as half. AB is given as 5. 5 by CD, which we have assumed as X, is half. So X becomes equal to 5 into 2, that is 10 centimeter. So the measurement of DC or CD is 10 centimeter. Moving on to the next question, here we have a parallelogram ABCD and the diagonal BD has been drawn and there is another straight line AE which intersects the diagonal at the point F. So now we have to prove this relation DF into EF is equal to FB into FA. So what we do over here is we take the triangles AFD, that's it, a triangle AFD and triangle EBF. EBF. In these two triangles, we get a pair of vertically opposite angles equal. That is, angle DFA is equal to angle BFE. One pair of vertically opposite angles equal. Now, this is a parallelogram, so angle ADF will be equal to angle EBF. These two angles will be equal. Interior alternate angle. These are vertically opposite angles. This forms a pair of interior alternate angles. So now we get two angles equal. So the third one is definitely going to be equal. Otherwise also, if you take the parallelogram, we know opposite sides are parallel. So this angle will become equal to this angle, interior alternate angles. So now we get in these two triangle AFD is similar triangle EFB. Because we have angle A will be equal to angle E, angle F, vertically opposite angles here, angle D is equal to angle B. So now we get here the two triangles being similar by AA criteria. So now if I write down the proportionality relation, I'll get here AF by EF is equal to DF by BF is equal to AD by EB. Now we have to prove this DF into EF. So we will take this proportion. We'll take this proportion, cross multiply it, you will get here DF into EF is equal to AF into BF. That was supposed to be. So this is how we work out simple questions on this. Moving on to the next one, we have here in the adjacent figure express X in terms of A, B and C. So here we have triangle within the triangle again. So now you can see this line angle is 35, this angle is also 35. And this angle C, if I talk about the triangle CPQ, and triangle CBA, we have angle C is the common angle in both the triangles. Common angle. Then we have angle CPQ. Angle CPQ is equal to angle CBA. It's given as 35 degrees. So both these angles become equal. So now we can write down triangle CPQ is similar to triangle CBA. So these two triangles are similar. And once we get the similarity criteria, the similarity is by AA criteria. We can write down the proportionality relation of the sides. CP by CB is equal to PQ by BA is equal to CQ by CA. From here directly you can write this proportionality, and if you are ever confused, you can look at the figure and check it out whether the proportionality has been written correctly or not. Now CP measures a C in units, so we'll replace it with C, small c. CB measures B plus C. PQ is measuring X over X units here, and AB is measuring A. We are not taking this into consideration because we have to write X in terms of A, B and C. So with the help of this first proportion itself, we can manage the solution. So now if we cross multiply X into B plus C will be equal to AC, which implies X is equal to AC by B plus C. So this is the final result, and this is the way we write down the result over here. So now these were very simple questions based on similarity. The next video will come across more questions which will be of a different level over here. Now before we move out, let us have a check on what we have learned till now. We have understood why enlargement does preserve similarity, because all sides increase in the same ratio. Why is AA sufficient to prove similarity but not congruency? Because angles fix shape but not sides. Does rotation or reflection affect similarity? No, orientation does not matter. Can similar triangles have equal areas? Then, yes, they can have equal areas. Alright, when the scale factor is 1. That means they are increased by 1 unit. Are all congruent triangles similar, and why? Yes, all congruent triangles will definitely be similar. An angle satisfy equal sides and equal angles satisfy similarity. What changes in similar triangle? When two triangles are supposed to be similar, what are the changes you notice in the two similar triangles? Say over here in this picture, you can see the two triangles are similar, but we can see the side lengths have changed, the perimeter of course will change, and the area will change. So these are some of the factors that you must keep in mind when you solve a question. With that, we come to the end of this particular video. Hope you have liked the explanation. If you found it helpful, kindly like it. If you believe in sharing knowledge, share it. Committed to learning, subscribe to the channel. Thank you for